Now let's discuss scientific notation. Scientific notation is a way of keeping track of our numbers that separates those two bits of information we've alluded to already in our discussion of significant figures. So we say a number such as this here has 3 significant figures, and this one here has 5. That's because these 3 here are the ones that actually tell us information and talk about how precise our measurement might have been. And these over here are simply telling us the size of this number, the relationship between these digits and the decimal point. Similarly, these 5 digits here are really talking about the information that we're talking about here, the valuable part, and really how precise that we were able to measure. Right? We weren't able to measure with 6 degrees of precision, shall we say. And then the rest, of course, are telling us that the decimal point is way out here. And of course, as usual, we don't always put the decimal point all the way there. We have no parts we are discussing. All right, now these are fine. These are fine, and you can read the precision right off the thing. You can read the significant figures, but there are some obscure cases. Like, say, for instance, if I take a ruler and I very carefully measure that the table I'm sitting at is exactly 900 millimeters wide. Well, if I go and I write 900, normally we would mean one significant figure by this, and yet I've carefully measured, and I'm pretty sure it's closer to 900 than it is to 899 or 901. How do I show that? There's a problem. Another problem arises with strange numbers. Say, for instance, I want to write, I'm doing calculations with the trillions of something. I don't know, imagine trillions of dollars with national economies, or perhaps we're talking about cells in our bodies, these kinds of things. Then you're literally looking at numbers like this. One calculation for the number of cells in the human body would be 14 trillion. Now, say I'm writing this out in several different places in a document or what have you. First of all, it's tedious. I'm not really keen on writing all 12 of those zeros every single time. And second, every time I write this number down, or one of its friends, one of its add-ins or something I'm subtracting from it, I have a chance of missing a zero. And what happens when I do? Well, I'm an entire order of magnitude off in my calculations. So these are two kinds of challenges that aren't really dealt with when you just put your numbers like this. So here's where scientific notation comes in. Scientific notation splits up a number into its significant figures and its order of magnitude. Significant figures we've seen already, and its order of magnitude is simply how big or how small it is. So there are big numbers like our 14 trillion, or some smaller numbers like our 478 10,000ths. These can be all put together in a nice tidy format. And here's the format. Write your significant figures. The decimal place is placed to the right of the first of those significant figures. That's standard. That's just how we do this. And then we account for having moved the decimal place, and effectively thereby account for the order of magnitude or size of this number by multiplying by a power of 10. So 10 to the negative third is 1 over 1,000. Perhaps you remember from algebra that something raised to a negative exponent is as though we did 1 over that number raised to the positive exponent. Well, 10 to the third, 10 times 10 times 10, or 1,000. Another example, and here's a large number being put into scientific notation. We'll take that large number that was here before, and we'll write it in scientific notation. Once again, we take those significant figures, write them out with the decimal point after the first one, and then we'll put everything else of this number into the power of 10. .9979 times 10 to the 8th